Hi Manisha, how are you?
Hi, Anna. Hi, good evening.
Yeah, good evening, Ma.
Yeah, I'm fine and I hope you're good too.
Yeah, I'm doing fantastic. Thanks for asking. And are you ready for mock interview for network engineer role?
Yes, and I'm ready for that.
Great. Sorry for the delay. And yeah, I was occupied with some other works and I took little time. Okay, so now let's start and introduce yourself, where exactly you're working, in which organization, what is your current roles and responsibilities. So based on that, we can continue our session. Okay. Yeah, please go ahead, Ma.
Sure. Anna. Yeah, thank you for this opportunity. Yeah, my name is Manisha and I'm an engineering graduate with the ECE as my mainstream. I totally have 3.8 years of experience in networking. I started my networking career in 2021, joining in a company known as IP Infusion. It's been 3.8 years for me, where in my first year I have been into operation team, where my main day-to-day scenarios involves troubleshooting of routing protocols, as I am into layer 3 project team. So I have been experienced on troubleshooting BGP scenarios and some OSPF scenarios, like if the session is stuck down in any active state something, so we will be troubleshooting like because of what case it is getting down, whether any if the port is not up, so we will be dealing like this troubleshooting issues. And in OSPF we have troubleshooted many cases. As currently I'm dealing with OSPF with as I'm owner of for VRRP, so we'll be dealing with more VRRP scenarios day to day life. And we also have some OSPF cases which like OSPF issues which have been troubleshooted more. And currently I'm into automation team too. So currently which I'm using existing PyLibs currently, but I'm focusing in learning of script too in current days. So I've been focusing in that too. So my day to day work depends on these protocols and these issues.
Nice,
Yeah,
fantastic.
thank you.
So yeah, so you're more into core networking and automation. That's a boom thing
Yes,
now.
yes.
Great, fantastic. So I'm going to divide this interview into two parts. Part one is about entire core networking. Part two is about
Mm,
automation. Okay. Yeah. So
mm,
let's concentrate this interview in core networking. Okay. Yeah, fine. So let's consider a scenario. Okay. I don't know about any technology. Okay.
okay.
I'm a
Yeah.
user. I'm just a user. So I
Mm,
purchased a new computer. Okay.
mm.
I have taken internet connection also. Okay.
Okay.
Okay. My new computer doesn't have any configuration.
Mhm.
Understood? My computer doesn't have any configuration, nothing. Okay. So I just open a browser in my new computer and just type www.tungabhadranetworks.in. Okay.
Mm,
So what is the communication from browser to Tungabhadra network server? So to communicate with server, what exactly I need step-by-step process for each and every aspect. Like whatever the configuration it requires, based on your ideology, right? What are
mhm.
the important things the computer need, and then go with the packet flow. Okay, yeah.
Sure.
You understood my question, right?
Yes, I understood. I understood.
Yeah, please go ahead. Yeah,
Yeah, normally if we buy one laptop, currently we will be having only physical address, which is MAC address. So for every device, we will be having that one by default.
yeah.
But if we come to the IP address, if we need to reach any internet or any service, like whatever HTTP, whatever else. So first of all, our device which we are handling, it need to have an IP address first of all.
Perfect,
So for that one,
perfect.
yeah,
I'll stop you and I'll ask you one by one. Okay.
yeah.
Yeah. So I need IP address, right? So I don't have IP address.
Hmm.
How will get IP address? Yeah, please go ahead. Yeah.
Yeah, normally if we don't have a IP address for our device, we can have it statically, like not automatically. We can configure it by our own. But what if the company is having some 100 devices? It's not possible for like manual work will be more.
Yeah.
So here we can use a thing known as DHCP server,
Okay.
which will be giving addresses for our devices automatically.
Okay.
So DHCP is nothing but dynamic host configuration protocol. That means which is giving the address dynamically for our device. So
Okay.
first of all, the process involves we need to enable DHCP in our device first, so that we can get to connection with server. So first of all, for connecting with the server, first of all, our PC will generate one discover message,
Okay.
but it don't know where it is and all. So first of all, it will be broadcasting the message.
Explain me the L2, L3, L4 headers. What is a consider your own thing. What is a client MAC address? What is a server MAC address?
Sure,
Consider
Anna.
consider these fields and generate a packet header L2, L3, L4 and explain me. Yeah, please go ahead, ma.
Yeah, sure. No. First of all, it is as it is in discovering stage. It don't know what is the MAC address, like something. What is the destination's IP addresses and all. So in first of all, in client MAC, it will be our own physical address, which is PC's one.
Okay.
In client IP address, there won't be any address as it is not unassigned. So it will be 0.0.0.0 because it
Perfect.
need to get assigned. So it will be in zero format. Now in client destination, so it don't know what is the destination's MAC address and all. So it will be FFF. It is which is broadcasting the packet and client IP also don't know. So we are giving 255.255.255.
Okay.
So once the discovery message is sent to server, now server will see this discover message
So
so that
you
it will get
missed
to
one
know.
more layer after IP header UDP. I mean
Yeah,
transport layer also should
yeah,
be
yeah,
there. Yeah.
transport layer. Normally the address 68 will be the port which is for PC and
Okay.
it will give the destination port as 67.
Perfect. Yeah.
So these are fixed
Now, yeah.
and
Now
it use
complete.
UDP.
Yeah. Sorry.
Yeah.
Now complete packet is generated. Discover packet.
Yes, yes,
Now as you
discover
said,
packet.
it went to server. Yeah. Now from server you
Mm.
can go ahead.
Yeah, yeah, and there will be also DHCP payload in which client MAC equal to it will mention its own MAC address. So
Perfect.
discover package is full now, so it will send to server. Now server got the discover message, but so it will know that yo some PC is asking me for a device allocation, so it will give some addresses. So there will be some network configurations which our device need. One is IP address and subnet mask for that IP address, and for DNS server for reaching any outside server. So we need one DNS server and also router gateway so that these all will be given from DHCP to our PC. But this will be given with offer message. In that offer, these are the options included. So the subnet mask having a DHCP option as one,
Okay.
and the router gateway which is having of three, and
Okay.
DNS server it is having of six, and there are and DHCP server identifier it is mentioning its own IP, so that will be as 54.
Perfect.
And one more is there which is giving us lease time, so I will be giving this much hours for you, so it is mentioning that one that option will be 51.
Okay.
Now total offer messages is generated, this is sent to PC now, but it is sent as broadcast because no server no IP address has been assigned to PC until yet, so
Yeah.
it is also a broadcast message. Now the source will be 67, destination will be 68 if we come to TCP.
Perfect.
So
Not
now
TCP,
the offer
UDP.
message, sorry, yeah, UDP.
Yeah.
Yeah, sorry. Yeah, now the offer message has been received to PC. Now PC will check all and now it will request the address. Okay, it's fine for me. Now give requested IP address. It will be option as 50. So it
Perfect.
will mention whatever the requested IP address given by server. It will mention that IP address and send the request message.
Okay.
And now what the server will do, whatever the columns it has been included all the options like server like address subnet mask call, so it will again revert back, like it will again send them the same in acknowledge message.
Okay.
So up to now everything is broadcast. Now our PC has been taken the IP address. So there will be a, DHCP server identifier or 54 and this requested IP address it is generated 50. Now it has acknowledged, yeah, I am giving this one. The process is completed. If we need to renewal sometime, so that message as the PC know it is server once it got IP address, so that it will be getting destination IP address and all clearly. So that if we need to renewal that time, it will be a unicast message,
That's
like
perfect.
not
Now,
broadcast.
now your
Yeah.
computer learn IP address, subnet mask,
Hmm.
gateway, and DNS information as well, right? Now,
Yes.
I just typed tungabhadra right? Now I have the IP address. Now, what is the process? Yeah, please go ahead.
Yeah. Now, if I'm typing www.tungabhadranetworks.in, I can remember as you as a company is known as the Tungabhadra Networks, but I can't know what is the IP address for that website.
Yeah.
There will be many more servers, but we can't remember.
Mm.
So that what the which will be remembering our cache, which is been local cache in our PC. If we have been typing first of all www.tungabhadranetworks.in, if it will check in our local cache whether we have typed it before, it has any stored content of that IP address.
Yeah.
If it is not, if it is there, so that we can generate TCP directly
Okay.
with 53.
Perfect.
If it is not there, so that we will be as we have got router gateway no sir with by using of DNS server, so the request will be sent to the IP like gateway which
Are you
has been
sure?
there ISP.
Are you sure? Just check it. Okay. So,
Yeah,
so what generate? So we doesn't have IP address of tungabhadranetworks.in. So what computer will generate?
it will generate recursive DNS query, like it will
Okay.
generate a query to the ISP.
ISP, right? Perfect. You have to
Yeah,
mention ISP, not device gateway. It's
yeah, get,
ISP.
yeah, yeah,
Perfect,
yeah.
perfect. Go ahead.
Because in ISP there will be also a catches, like our device has local cache of all information. There will be also having a cache which is recursive DNS server. We name it
Yeah,
as.
yeah.
So the request will be gone toward using UDP port 53 here.
Perfect.
So what we are doing, it will check in its local cache whether it is presented or not. We are
Yeah,
sending it recursive. That means PC need exact IP from the server, no, not of any. If IP address is not there with you, give me other server. No, so it need only the IP address. So we are generating recursive query here. Now what server will do? If server don't have that address, so it will generate to Google servers
yeah.
with iterative query. That means
Are you sure?
if a request
Is it Google server?
there will be some servers which will be like firstly we are sending for a root server.
Yeah. Now you are
Yeah, first of all
right.
we are sending for root server here. So this root server if it will be it will be giving the top level domain server address for the our ISP, so
Perfect.
that it can generate again the request to the top level domain server. So which have all www.com like details and all in this top level domain server. Now top level domain server also like it will say okay this address will be having with authoritative server. So this is the last server. So this authoritative server will be having all the information of this Tungabhadra networks, Google.com IP addresses. All the IP addresses will be present here. So that lastly our ISP will generate the query to authoritative server. So that this authoritative server responds with IP address of Tungabhadra networks.in. Now, firstly, what the ISP will do, first of all it stores, because every time if some other PC is generating, it can't
Yeah.
again do all requests.
Yeah,
So
yeah,
first
yeah.
of all this will what it will store that IP address. After storing that it will give to us. Our PC also do the same, like
Yeah.
rather than asking more time, so it will generate, like it will store that one. If we type again, so it will directly go to TCP connection as it
Yeah.
has that IP address of
So
Tungabhadra
now,
network.
finally, IP address of Tungabhadra networks, you learn it. What is the next? You said
Yes,
TCP connection, right? What is the TCP
yes.
connection from client to the Tungabhadra network server? Explain me headers, layer to layer to layer 4. Yeah.
Yes. Now we got to know what is like if we are connecting from using TCP, it is a it will follow three-way handshake. Why we are using TCP? Because it is reliable.
Yeah.
If we are sending any data, it will like it's pakka, like it will we will get the data which is been from source. It will be definitely reach to destination, because here it is using packet switching, because everything will be divided into blocks, so it will be stored. If any block is missing, again it will retransmit. So TCP uses this one so that we are safe using of TCP for any data transfer.
Yeah.
It is not in the case of UDP, because if any data is missing, it won't take chance of like sending again. So it is unreliable. So here TCP, if we need to establish TCP connection, we need to have first of all three-way handshake. We need to do this one so that we can have communicate. Like if they are directly connected, also we need to do this establishment, so that from source to destination we are doing three-way handshake. First of all, from our PC, we will generate SYN packet,
Yeah.
which will be having source port, destination port, and some control bits.
Yeah.
Like we'll be having main control bits here.
Explain me with L2, L3, L4, step by step, slowly. Yeah. What is the TCP packet will generate, right? SYN. So what
Hmm.
is the L2 fields? What is the L3 fields? What are the L4 fields? Yeah. Go ahead.
Yeah, in L2 fields, we will be seeing our source MAC and source and destination MAC. In L3, we will be saving our source IP address from where we are pinging and the destination one. Now, in
Destination
between, we are
IP.
using
What is the
this
destination IP here?
whatever like currently we are pinging from TCP,
Yeah,
right?
yeah, yeah, yeah. It's Tungabhadra Networks IP. We are pinging Tungabhadra
Yeah,
networks. Yeah.
servers to that server. Yeah, now we need to establish the connection, so that here we will be using, like if we are using HTTPS, it will be 443 the destination.
Yeah.
Source will be random, anything it
Perfect.
will take in that random.
Perfect.
So the destination, there will be destination ports are particular, there are well known ports which are designed for some servers, like they have been already committed.
Yeah.
For HTTP we have 80 like this.
Yeah.
So that the TCP will be sending, first of all it will send by setting SYN packet 1, it will send to server,
Yeah.
so that the server receives it and it will acknowledge by sending its own SYN plus acknowledge to our PC.
Perfect.
Now after receiving that acknowledgement, then we get to know, okay, now I have been able to connect, so that it will also get acknowledgement. Now TCP has been established perfectly, so that now transmission we can have.
Yeah. So now
Next
three-way
we will be
handshake.
having
Yeah.
some TLS and all.
Yeah.
Yeah,
That is next layer. That is okay. That is
next
okay.
layer. Mm,
It's two now. That's fine.
yeah.
That's completely security side. Perfect.
Mm,
So three handshake process is completed, and now your
yes.
TLS handshake is also done. Now you will be able to access the data which is stored in application server. Yeah,
Yes.
perfect, perfect. This is what the company is looking for, not straight onwards, straight questions
Yes,
and
sir.
answers. This is how. Okay. Now what we have covered everything. DHCP, DNS,
Everything
TCP.
DHCP, TNS.
Yeah, perfect,
Yes, sir.
perfect. Okay, now I'm going to give a scenario. Okay,
Mhm.
so I have two PCs. It's a newly fresh PCs, fresh
Mhm.
computers. I have assigned IP addresses also. Consider here 192.160.1.1/24, 1.2/24. Both are in
Mhm.
same network, blah blah blah. And now,
Yeah.
you know, uh, those are connected to the switch. Okay. If I initiate a ping
Okay.
from PC1 to PC2, will it ping or not? If it is ping, what is the explain me the packet level process. So, yeah.
Yeah, sure enough. Now, as you said, PC1 and PC2 in same network, because we know like 1.1, 1.2, but our computer don't know because
Yeah.
it won't understand this one. So what it will do, it will only understand zeros and ones. So whatever we are giving, it will convert that one into binary format, and it will do AND operation
Yes.
between our source address and the destination, like between the destination address and the subnet mask, so that it will calculate and it will get to know first whether it is in same subnet or different subnet.
So
So
once you
here
do once you do under operation between source subnet mask and IP address, what you will get?
we will get one address which is in particular subnet, so that you will
So what
compare
address it
like
is?
these are
That address we call
uh,
what? There are two important addresses, right? In any IP network.
network portion and
Yeah. What is that?
broadcast portion,
Yeah.
network
Network
host,
address.
broadcast host, yeah.
Got it. Got it. Network
Yeah,
address.
which is our dot zero, like host will
Yeah.
be zero, it will be starting from there.
So you mean like
Yeah, now,
after under operation, we'll get a network address. Okay.
yes
Based on
sir.
that, it will compare it, and yeah, you'll come to know both are in same
Yeah,
network.
it
No
will
problem.
get to know whether it is in same subnet or different subnet. For same subnet, the scenario will be different in case, and for different, it will be in different scenario. Currently, we can discuss with same subnet.
Yes. Yes.
So now,
Now.
what
Yeah.
will be? Yeah. Now, first of all, we there will be an ICMP echo request as we are generating ping. Ping uses ICMP protocol, which is of protocol 6.
Yeah.
So sorry, protocol of 1.
One. Yeah. Yeah.
Yeah, 1
Protocol
protocol
number.
of 1. So yeah, protocol number is 1 for ICMP. So what will be PC1 is generating ICMP echo request. What are the fields in it? It will be having source MAC. It will be having first source IP. It knows its source IP, and
Yeah.
it will know the source MAC. Now it will know destination IP as we are pinging, so it will get to know
Yeah.
destination IP,
Yeah.
but don't destination MAC. So the field is empty. So we can't
Correct.
generate this packet to the other switch, or we can't send it to switch now.
Correct.
So first of all, we need to have that MAC address. So for having this MAC address, we can use a protocol named as ARP, which is known as Address Resolution Protocol. It is a layer 2 protocol, but we are using it for layer 3 addresses for knowing of these MAC addresses. So what will be the ARP content? Like why we are using ARP now to know the MAC address of the destination one. So we will be generating ARP request here. So what will be the fields here? Source MAC, destination MAC. So here source MAC will be our PC's address. Destination MAC will be broadcast because it don't know which one we are
Yeah.
generating.
Yeah.
So it will be a broadcast packet. So the
Just,
switch receives
just
it.
sorry to interrupt you. It's a ARP request
No
packet,
problem.
right? So in ARP
Yeah.
request packet, I'm just giving a hint. Is it really we called as a source or any other keyword?
No, like target IP we can call and
Yeah.
sender IP target
Yeah.
IP. Yeah.
Mention the keywords are
Yeah.
very
Yeah, sure.
important. The
I will
intention is
include. Yeah.
same, but yeah, just
Hmm.
yeah. Now you can generate ARP request packet with this use these keywords.
Yeah.
Please go ahead.
Yeah, this is the target type. As we know, the target MAC will be FFF because we are generating a broadcast message,
Yeah.
so that switch receives it. So that whatever as it will see that it is a broadcast message, how many devices it is getting connected, it will connect. It will
Yeah.
send. But currently we have only PC2, so it will send to PC2. But before sending it, it will store the MAC address of this PC1, so that
What
as it got received. Sorry.
MAC address in PC1 or MAC address
No,
table
no,
of
I'm
switch?
just talking about in switch. In
Okay.
switch MAC address table, it will get stored.
Okay.
Like from this interface, we are just connecting this PC. So
Yeah.
MAC address is of this one. Now
Perfect.
this will send a packet to PC2. Now PC2 received it and it will check. Okay, the IP address is of mine. So it will respond with its own MAC address and it's ARP response. But it knows source port like source IP, like sender IP, target IP. It know everything. So no need of broadcasting again. So it will do unicast to switch.
Yes.
Now switch. Now it will store PC2's MAC address in switch. Now it will send the packet as it is. No, it is received from A, so it will send to A. Now A got MAC address of PC2. Now everything in ICMP echo request is fulfilled. So we can generate ICMP echo request to PC2 from via switch. Now switch knows which is the MAC address of PC2 because it has been showed while our response is coming back.
Yeah.
So that it will generate to PC2. So now as it received, it will see its own IP address so that it will respond back to PC1.
Yeah.
So this is the entire process of
Yeah.
for networking switchable,
Perfect,
how it ping
perfect,
works.
fantastic. And only one small thing is missed. Like once the ARP
Yes.
request is received on PC2, right? It will learn that source MAC and IP in ARP table.
Yeah, yeah. It will store in ARP cache.
ARP table.
Yes.
That is the
I
only
missed
thing,
this.
and everything is perfect now. Fantastic, good job.
Yes. Yeah.
And yeah,
Thanks.
yeah, this is all about basics. And I have
Mm.
some few straightforward questions. What is the TCP port number for SSH?
For SSH, it's 22 one.
Telnet.
23.
Okay, DSCP you already mentioned. Okay, and what about HTTP?
HTTP, it's 80.
Okay, what is the protocol number of TCP?
Uh, 6.
Perfect, perfect, good, good.
6.
What is the protocol number of UDP?
I'm not
No,
aware.
no, not a problem, not a problem.
Yeah.
So where you will see this protocol number, in which header you will see?
We'll see in IP header, and as it is above, so we
Yeah,
can see in IP header.
perfect, perfect, fantastic, ma. Good. And yeah, coming to the routing and switching, basics, network
Sure.
fundamentals, it was fantastic. So
Yeah,
happy.
sure.
Yeah, next,
Thank you.
so which routing protocol you're familiar with?
Yeah, I'm mostly familiar with OSPF and also BGP is also fine for me. I'm
Okay,
familiar with both.
okay. I will ask you straightforward questions. Okay,
Yes.
I'm not expecting any abbreviations. Don't tell any abbreviations.
Sure, sure.
I'm telling
Yeah.
you. Okay, yeah.
Hmm.
So what is OSPF?
Yeah, normally OSPF is a routing protocol which we are using in routers. We have two types of routing protocols, like three we have. One is default, static, and dynamic, which OSPF comes under dynamic routing. That means if we are using this OSPF routing protocol, no need of adding any routes manually. It will learn automatically from the other routers. So this is the purpose of using OSPF. That means OSPF is a dynamic routing protocol which is used to learn the routes automatically. So
Perfect.
it is a link state database protocol.
Yeah. In my experience, no one tell this perfect answer so far. This is a
Thank you.
wonderful answer. Candidate should learn this because if
Yes.
anyone asking what is OSPF, it is a open shortest path first. That is blah blah blah. That is a shitty answers, which is this is
Yes.
it will tell you the bookish knowledge. Okay, this is a perfect thing.
Mhm.
It's a routing protocol. It learns the routes dynamically. That's a fantastic
Then,
answer, ma. Now,
yeah.
how many OSPF packets we have?
Yeah, we have some five packets, which is of hello packet, database description packet, link state request, and it will be update and acknowledge at last. Link state acknowledge.
Okay, so just briefly, don't no need to go
Mhm.
into the deep level. I understood you now. You know the deep level also.
Mm,
Just
yeah.
explain me if I configure OSPF between two devices, what is the adjacency process? How many states we have? Where these packets will get involved? And explain me with these packets entire OSPF adjacency process. Please go ahead.
Yeah, sure. And normally, for establish any OSPF session between router one and router two, it need to go some session like some process. Like there are seven states where until it's get to full, it need to go through this. Like first is down, init, two-way, extart, exchange, and loading and full. So I will explain one to one what is the thing. First of all, in down state, it will there will be OSPF header and a hello packet. In OSPF header, we will be having some fields like which is the version, what is the router ID. We will be having this authentication data, authentication type. So
Yeah.
these are some of the fields which will be there in OSPF header. Now, and also there is OSPF packet, which includes of like network mask and the hello interval, like after how much hello interval, dead intervals, and also some we can also having priority. So that this is the thing which is there in hello packet. So it will send this OSPF header along with hello packet and move to init state, like for which it is sending for R2. Now R2 has received this packet. Now what this R2 will do, it will check this. The first of all, this packet will be sent using multicast address 224.0.0.5. So now as OS like R2 the second device has been received, it will check all the fields whether the fields which it has and the fields it received are matching or not. We can have router id as different because it need to be different, and it will check for hello interval, everything like process id are the same. So it will check and all, it will after checking it will respond with a field known as my active neighbor, like it will respond with that R1 router ID. As of now, as of if it R1 sees this packet with you are my neighbor ID like that, so that it will also send the packet like it will also send like it, you are also my active neighbor, so it will move to two-way state here. This is the state where both have been discovered, like neighbors have been discovered here. Now hello packet has been done. Now in two-way state we need to elect any, like as we know there are we will be having database description packet, where here like we said DRBDR elections happens here, which is called
No,
designated router.
you're talking about which state?
Like I'm starting one second,
You
start
said DBD,
exchange,
right?
right? Yeah,
You're using the DBD packet. So
DBD
that
packet.
means it's a start state,
No,
right?
no. In extart state, yeah, it will use MTU bit. So in two-way state, it will be DVD, like
Yes.
DRBT elections happen, which is based on the router ID and all, which is having
Yes.
like priority and all, which is having highest router ID and highest priority. So it will become as DR. So that here it will generate type 2 LSA. As we know, there is type 2 LSA, which is known as network LSA, which is generated by DR. Now, after this one, it will coming to Xstart, where we will be having DBD packet. From Xstart sheet, it is unicast as they have been discovered. So, no need of sending again multicast here. So, it will be unicasted here. So, what it will be doing now, database description packet, we will be having some fields like MTU, which is the main thing in Xstart state.
Yeah.
MTU. So, we will be having MS bit like master slave. So that there will be MS bit. First of all, they will generate both as one. After seeing the routers address and all, which is having highest routers, they will be uh, setting ms equal to 0, another one will be setting ms equal to 1, so they will generate type 1 LSS here. Now the next one is exchange here. Whatever the things, like if they are missing any things like that, will generate all um, routes and all. So the next one is loading. If we have, if for example router 1 is connected with other area, any other thing, so there are some more routers, it will be connected as ABR, so it will need to generate these routes to other also. So in loading state it will follow all this process, like if it has any extra routes it will send to
So you
R2 and
mean
it will have.
you're using the keyword routes. Generally, those routes will carried in which type of packet, you can say, type of packet
L,
like yeah.
like LSA packets we are setting
Yes,
link state advertisement packet.
mention LSAs, not routes. Okay, missing
Sure, and
LSAs.
okay.
Yeah, yeah, yeah.
Missing
Please go ahead.
LSS. Yeah,
Go ahead.
whatever the missing LSS, they will be stored in loading state. Now the database is like both OSPF database are same.
Yeah,
So now there is the, now the next state is full. Now the status is full. We can see OSPF neighbor as, if we search for show IP OSPF neighbor, the session will be shown as full. So they have been exchanged all the information between them.
yeah, yeah. So database synchronization is completed. Now they have their same database, same area. Perfect.
Yes, yes.
So once the database synchronized, what will happen after synchronizing the database?
Sorry, sir. Sorry, Anna, can you
Yeah,
ask in
what
detail?
I'm asking is now database synchronization is happened. Both the routers have same database. Now, what is the next step? There is a final step is also there, right? After learning all the LSAs, database is synchronized. It is in full state. After full state, what will happen?
They will exchange the routes, like it will
It's
it,
done.
no, first of
Exchange
all
is
after it's done. Yeah, now what it will do, as it is connected with many of the, like many of the sites, so it will do Dijkstra algorithm, SPF
yeah,
algorithm, which we can
yeah,
say. So that which the importance of this is to find the best path.
yes,
Normally OSPF is a link state, so it will find it based on the cost, it will decide like
yeah.
which path it need to transfer the routes on, like
So
which
it will,
need to go
yeah, it will run the discussed algorithm. Then it will populate the best
algorithm.
paths in routing table. Yeah, that is
Yes,
the point I was asking. Fantastic, ma. Great.
yeah.
And now, if my OSPF stuck in XStar state, what could be the reason?
Yeah, if you know there are these are this is extart is one of the state which comes before having the neighborship as full. So in extart state, the main issue which we can see is some MTU mismatch.
Yeah.
For example, here you have interface H0 and something H0. If you are giving here 1400, if you are giving 1500, 1500 has the capability of loading 1400 bytes,
Yes.
but
Yes.
1400 won't be having the 1500 bytes loading. So
Yeah.
here it will be stuck. So based on the MTU mismatch is the main problem in extart state. So we
Perfect.
can see this issue here.
Perfect. Yeah. Coming to BGP, how many BGP messages we have?
Yeah, we have some files, say open message, keep alive message, update message, sorry, notification message, update message.
Perfect. So
Four
now,
messages.
how many states we have in BGP? Explain me the step-by-step process. Yeah.
Sure, sure. We have some six ideal, connect, active, open send, open confirm, and establish. Some six states we are having in BGP. The first three state, which is ideal, connect, and active. So as we know, BGP is used for use, like BGP is established using TCP connection, which uses destination port 179. So this is the port number for TCP. Now from ideal, it will send SYN packet to the R1. Sorry, R2. Now R2 receives. If the R2 like a response with SYN plus ACK packet to R1, so that it will go to direct as it came to connect, so it will directly go to open center. If in case if there is that 179 port is not been there something, if any issues happen here, it will be in active state if it won't receive this synac packet.
Yeah,
So it will be buffering there itself, it will go to ideal active again, ideal active again. So this will be a one issue. So if it is been like synac packet has been received, it will go to open center.
yeah.
Now
In
after
case,
open
in
center,
case Synac is not reached here in connect state, what will happen? You said it will go to the active, but there is a timer, right? Mention the timer. You
yeah,
know
so there
that?
will be some 180 seconds which default,
Yeah,
like BGP uses defaultly. Up to that one, it will be sending SYN packet continuously like that,
certainly.
based on the time received.
So
So next, from open send, yeah,
let me explain. Yeah, up to 180 seconds, it is waiting for the SYNAC. Upon receiving
yes,
SYNAC, it will move to the open confirm. In case if it is not right, connect retry timer will reset again. It will start from count 0 and move to the active state. Again in
yeah,
active state, it
okay,
will
okay.
start initiate new session as you said, right? It will
Mhm.
buffer. It will jump from active to idle. And
Ideal to active again, yeah.
perfect, perfect. Now TCP three-way handshake process is successfully established. Now next state is open send state. Yeah,
Yeah, no, after like as we know in OSPF, in two-way states neighbors has been discovered. In the same way here in open send state, BGP neighbors has been discovered here. So in open send to open confirm here, the routes which are been there in BGP like network 2.1 we will be giving these types, no sir. So we will be exchanging those which are in, like first one is open message, keep alive message. So in update message, all routes will be sending here. At last is notification message. If is like sorry, yeah, notification message. If we see any errors or
wait,
if
wait.
it's
Generally, you are mixing all the things at the same time. Go slowly, okay?
okay,
Open send state. Open message will go. Then
yeah,
parameters will match, and then it will
match.
advertise keep alive. Once you
Yeah,
receive keep alive, it will be open confirm, right? So yeah, continue now.
yes, sir. Yeah, now open. It will send the. It will check the parameters which has been sent in open message like BGP identifier, router. It will be sending. It may like ID need to be say no. It's not required of same. So we are having different tests also. It will be fine. If we are any authentication, it need to be matched. If we have configured any authentication, so
Yeah,
now open send to it will send to open confirm. Now open confirm to it's been established. So now from sending in open confirm, there will be this. We said to keep alive message, update messages.
yeah,
So where we will be having these routes, BGP routes, which we have network one route. So these are the routes which will be calling here, some prefixes and all. So
yeah,
these will be transferred here.
yeah.
So at last, the session is called established state, where BGP neighbors have been fully established.
Perfect, perfect, and updates also been exchanged. Perfect, ma.
Yeah.
So how many attributes we have in BGP?
Yeah, we have well-known attributes and optional attributes. Which we in well-known attributes we have mandatory. That means whenever a prefix is going to other, they need to be gone with the router also. They need to follow it like next hop address, AS path, and origin value, whichever the origin the route has
Perfect,
been containing. These are the
perfect.
mandatory. In discretionary, we have local preference. One is the main of the thing is local preference, which is local to AS. It
Perfect.
won't be advertised to external. It is local to the AS. If it AS 100, only the AS 100 will receive this local preference. And optional in we have like I know one MED value,
Okay,
and some BGP community attributes were there.
okay,
Yeah.
perfect, perfect. That's
They
fair
are
enough.
called a transitive, non-transitive. Yes.
Yeah, yeah. So now, what is the BGP path selection process? Suppose I have a Google route in my routing table.
Mhm.
In BGP table, I have two paths, two or three paths, multiple paths to reach the same destination. What is the
Yes.
BGP
Yes.
path selection process? Yeah,
Yeah, the BG Pro path selection mainly involves the attributes. Based on these attributes, it will be
yeah,
involved, like it will be selecting. The first thing will be the next hop.
yeah.
First of all, it will check whether the reachability is there. So
Perfect.
actually, there will be next hop reachability. Now it will check lowest AS path. There will be a community like BGPS
Lowest
prepared.
is path
We
or
know.
what? Second one is recall it. First is
We'll be
next up.
next hop IP address origin, and
No,
we'll
no.
be
First
having
one
this
is next up. The second one itself is what? The
local preference.
perfect. So yeah, go ahead.
Local preference, local to AS, yeah.
Yeah.
Next up, it will check local preference and it will checking the AS
Local
path. Less
preference will
AS path
be
is preferred.
local preference is high or low. Mention that as well.
It need to be highest, sir. High
Yeah.
local preference is preferred.
The next
So
one
on
is
low. Yeah, and low AS path is preferred. The
Shortest,
router, the
shortest.
prefix, yeah, shortest AS path.
Okay,
And we'll be having less origin preferred, and lowest MUD value. Like, so it will be calculating likewise.
okay.
If the local preference is high, so it will prefer the first one. Like, this is the stages. First, next stop,
Priorities.
local
Yeah.
preference, yeah, priorities.
Mm.
And the next one is like we have lowest AS path and lowest origin and lowest MUD. And if all is matching, it will prefer EBGP or IBGP. Mostly EBGP is preferred,
Mhm.
and also some we can say if they are also prefer, if they are also same, so yeah, the oldest route which it has in IP routing table, it will
Perfect.
prefer that one and it will go to.
Perfect. That is fair enough. That's fair enough globally. Perfect. Okay. So let's coming to switching as well. Okay.
Sure.
What is STP?
Yeah, normally if we know in our networking itself, the main issue is looping. If we are connecting router 1 to router 2, if again router 2 is connected to router 3, now router 3 to router 1 is again connected. Whichever the information router 1 is generating to router 2 will send to R3. R3 will again send to R1. That means
Router.
looping will happen.
Why router comes to the picture?
Sorry, we can come to switch one. Sorry. They
Yeah.
sorry switch.
Take a
If
breathe.
we are having
Take
switch
yeah.
one,
Take a
sure.
breathe. Do not miss it. Yeah. Please go ahead. Yeah.
Yeah. Yeah, now we are discussing STP, right? Sorry. Yeah, STP is the protocol which is used in switches, so
Mm.
for avoiding loops. So
Yeah.
that the main usage of STP is for avoiding loops.
Yeah.
So STP is a spanning tree protocol which is defaultly enabled in switches, no need of manually enabling it. So
Yeah.
it will be defaultly enabled. How this process work means, let's take off having switch 1, switch 2, switch 3. They are connected in switch 1 to switch 2, switch 2 to switch 3, again switch 3 to switch 1. So as switch 1 will be sending packets, the switch 3 will again send to switch 1. So here looping will happen.
So
For in
what?
this case, what we can see,
Which will send a packets or frames?
it will switch will send frames, sir. Sorry,
Okay.
frames.
Frames.
In
So
later we can
what
see
is those?
in switch we can,
What are those actually? Which will generate?
normally for electing STP we can use BPDU frames which have
Yeah.
been broadcasting from switches.
Yeah.
So that now for if we need to stop this looping, we need to remove the switch 1 to switch 3. So this will be not the case.
Mm.
So what we are doing, we are using STP here. So no need of removing it. We can have it, but we are just disabling it.
Yeah.
How we will be disabling? By electing first root bridge. In all switches, we will elect one root bridge as a leader. We can consider as root bridge.
Yeah.
So it will be based on the priority and MAC address, which is lowest. So
Yeah.
it will be considered as a bridge ID.
Yes.
Sorry, root bridge. It is bridge ID
It's
is
a
equal
bridge
to
ID
priority
only.
plus
It's
MAC
a bridge ID only. The lower bridge ID will become a root bridge. That's
will
correct.
become a root bridge.
Yeah.
Now there will be now root bridge has been elected. In remaining switches, this root bridge won't participate here. Now in remaining root bridge, we need to elect root port. So
Yeah.
the root port will be elected based on the which have the lowest cost to reach the root bridge.
Perfect.
Like based on the cost test, we are using cables interface, right? Based on that cost test, we will be using that one. So for 10 GB, we will have two like cost differs. So that we'll be using like this. Now root port has also been elected. Now between router 1 to router 3, we need to enable whether router 1 connected interface or router 3. So we need here whichever having the highest bridge ID, so it will be disabled, and which is having it will be inactive.
Yeah.
In case of any link goes down, it will come to like this will get active. But here the default like the disadvantages of convergence time.
Yeah.
It will from blocking to forwarding, it will take 50 seconds to come up.
Yeah.
Like blocking, listening, learning, forwarding. That entire time taken is 50 seconds. In order to reduce it, we have a concept known as RSTP. It need to be manually configured by the user.
Yeah. So
Yeah,
if I
this is about
configure
STP.
if I configure RSTV, what is the network convergence time you see?
Yeah, it is so fast than STP. We can consider between 12 seconds to 15 seconds itself. It will come up.
Yeah. Perfect. Okay. So now coming to what is BDU got?
Yeah, normally the BPDU code is the one which can be used. For example, let's take on switch if you are configuring port first. Port first is a concept where it will directly from blocking to it will directly come to forwarding state. It won't go to listening, learning when the
Mhm.
failover is happen.
Yeah.
So in this case, what will happen if BPDUs are being broadcasted? It will receive the BPDUs, but it won't even check. It need to be root bridge, root, but it won't even elect. It will directly forwarding to other. So
Yeah.
looping will like it will be the performance will be low. So if we are if we are enabling port first on particular switch, if we need to have if we have these disadvantages of like BPDUs receiving and all, it won't check and all. So if we enable BPDU guard on that switch, so what this BPDU guard will do, whenever it receives any BPDU frames, it will immediately stop that stop that interface to, it will set it to error disable state.
Perfect.
It will shut. If we it is an issue, so we need to manually do no shut again. So
Yeah.
it will go to error disabled state. This
Yeah.
is use of BPDU card here.
Okay. So to protect from unwanted BPDs from the downstream
Yes sir.
switches. Okay, cool.
Yeah.
So yeah, you're almost there with all. And coming to VRRP, your favorite one. So tell me,
Yeah.
Ma, what is VRRP? Why we use VRRP?
Yeah, normally if we know in any of the companies they will using redundancy ISPs, like we'll use it, we call it as redundancy purpose, because we are using two ISPs for redundancy purpose. If it gets down, we need to use other one.
Yeah.
What if our routers will get down in between?
Yeah.
So this is the thing where VRRP gets into picture.
Mm.
Let's connect PC1 is there. PC1 is connected to switch. Switch is connected to routers. So in these routers, I will be configuring VRRP for usage of, if this router R1 router goes down, the PC1 needs to ping the internet via PC2 without
Okay.
any disturbance or ignorance. So this will be done. This will be done using VRRP. So this is nothing but gateway redundancy protocol. It is for gateway redundancy.
I was
So
expecting
we
that
will be
keyword,
config
gateway redundancy.
gateway. Yeah, it's a
Yeah.
gateway redundancy protocol. It will be elected. There are two cases. Like one is master backup.
Yeah.
So master is elected based on the on which router you are giving high priority. For example, if you think I need to send my traffic from R1 itself, I need to receive something. So that we can mention is that master by giving priority higher
Yeah.
than R2. So the all the
Yeah. Yeah.
packets the PC1 reach the internets via master. If in any case it goes down, it will go via backup.
So how it will go via backup? How PC2 come R2 comes to know master is down? How internally?
Yeah, normally there are VRRP, which we call VRRP advertisements, which are sent every second as it
Yeah.
need to be faster. So
Yeah.
it will be sent every second. Whenever it won't receive VRRP advertisements from master, it will say something is happened to this person. I need to be active on now mode. So it will
Yeah.
become as master here.
Perfect. 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 So it is, if it is connected to the switch, there in the switch there's a MAC address table, right? How come the switch will come to know, okay, this R1 is down, I need to send a traffic to R2? How switch learns the MAC address? This multicast, VRRP packets will exchange through multicast, right?
Multi.
So what is the MAC address
Yes,
of
yes.
that multicast? Do you remember by any chance?
Yes, it's 224.0.0.18.
18 is the IP. What is the MAC address?
MAC address, like it starts from 01005.
Five, yeah,
Multi-guest MAC
five, yeah,
address. Yeah.
yeah. Great, great if you remember that. That MAC address is learning in MAC address table, right? Suppose whatever the interface which is connected to the R1 from switch, right? That interface it's up, and however R1 is down. Okay. Now how we choose R2 as a gateway? How the switch is forwarding the traffic towards R2, because R2 is backup, but how comes to know switch comes to know that? Yeah. Do you know that?
Yeah, yeah, I got your question, sir.
Mm.
Yeah, normally we are having R1, R2 connected both to switch.
Yeah.
What I said, master will be sending VRRP advertisements.
Yes.
Until unless master gets down, then only backup will send advertisements. That
Yes.
means any one port is active. From if it is receiving from backup, it will store the MAC address of this switch here. It won't, the MAC address which is being sent from master, that interface, it won't be there. Now it will be given here. So there won't be any advertises from master. So it won't check anything now. Now the MAC address which is there is from switch 2, like which is the we are giving from interface. So at once there won't be the MAC address stored of router 1 and router 2 both in switch. So this is where we can use this VRRP, so that if one is down, it won't be here. Now this connection will be enabled and the advertisement will be sent via this one.
So how come MAC address is learn? How MAC addresses will learn? Generally, MAC address table, how it will populate initially. Know this thing. It's ARP, right? Based on ARP
Yes,
approach.
yes.
Now
Huh.
here, how the MAC address is populated with the R2's gateway. So generally,
Yeah, because yeah.
what will happen, So
Hmm.
the master stop advertising VRRP announcements, right? If it stops, the R2 becomes master. Before taking master ownership, it will generate a gracious R. Is there any duplicate
Mm-mm.
virtual MAC,
Yeah.
virtual IP that whatever the gateway you're configuring? It will generate a gracious ARP, it will send to switch. Now switch learns the MAC address of that gateway based on the gracious ARP. Okay. So
Okay.
that
Okay.
process will happen. I explain this as well. Okay, just remember this, very important.
Okay.
And
Yeah. Okay.
apart from this, if you see both the VRRP routers in master, this is the issues. VRRP announcements may not be, yeah,
Yes, sir. Yeah, normally, as per my knowledge, if ARP request is generating from PC1, backup won't reply at any way. Master only replying so that the traffic will be generating.
PC1, PC1, not PC1, PC1 will not generate any ARP. The
Okay,
router
okay.
2 will generate gracious ARP, not ARP, gracious ARP.
Okay, keeping same address. Okay,
Yeah.
got it, got
So
it.
right,
Yeah.
gracious ARP will check the duplicity in IP before.
Yes, 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 sir.
So that virtual MAC address, right? Virtual IP,
Hmm.
we are configuring a virtual gateway, right? So
Yeah, same address.
is this gateway is configured anywhere? It will generate again a checking a duplicity for
Okay,
virtual
gracious, sir.
gateway,
Okay.
gracious ARP. It's a gracious ARP which is generated from R2, not from PC. Yeah, that's how the MAC address is populated. Yeah,
Yeah,
perfect,
okay.
ma. So yeah, your interview is fantastic. It was like everything is good. Same like Uma, you were like awesome. You were like fantastic, ma. I'm so happy. The only thing is you guys are going like jet speed. Okay,
Yes, yes, okay. No.
just slow
So,
down little bit, and it is everything is fantastic. Okay, your part one is successfully completed. So tomorrow I'm going to take a automation, how you integrated networking automation, here.
yes,
So
sir.
I
Okay.
explained you everything, right, regarding
Hmm.
real-time projects and all. So yeah,
Yes, sir.
prepare well, take how many days you want, prepare well, and yeah, I told you, right. I we can check quickly after this session your resume. I have to refer
Yes,
him.
sir.
So candidates need a persons like you. I was very happy. It's a back-to-back blockbuster, you can say. Like a batsman is doing century, right? For me, I'm a teacher. I'm a tutor. Whatever I'm explaining to you, right? The same thing. If you candidate is learning, it's like overwhelmed for me. I was very happy for you and Uma and yeah, so many candidates. Seriously, it's a very good positive for me. Thank you for you made my day
And
again. Thank you.
yeah, I
And
can genuinely say, as I have 3.8 years experience, but I can only consider 5 months experience after joining yours, so that I got all the concepts of networking.
yeah,
Like whichever I have been worked, now I got to understand. Okay, this is for this purpose. This is for
yeah,
that purpose.
win.
Otherwise, I'm not shame of telling I don't even know this VRRP, MAC address. I don't know anything. At
Yeah,
least I don't know it's going through multicast IP also.
yeah,
So
yeah.
after joining here, like you are like pro. That's it.
No, I'm just like
You know
you.
that.
I have just good at basics, little. Same thing I'm explaining since I'm working in a product base. So I want to give equal knowledge to you guys. We need to rock in product based companies. That is my passion. That is my dream. My candidates
Yes,
should
and
be
as
working.
your
Yeah,
students, we need to gift you by joining product-based companies itself,
yeah,
so that your teaching is have been fulfilled for us.
yeah. So, yeah. Thank you so much. If you're succeeded, I'm automatically succeeded dynamically, you can
Yes,
say. Yeah, fine, ma. It was a fantastic interview. I didn't even know the time actually. It was 1 hour, right? It was like
yes,
because
and
of your fastness also, I asked so many questions. Seriously. I
yes,
covered
yes.
basics, I covered routing and switching, OSPF
Yeah,
and
I think we covered
CCNA,
every concept here.
every
Yeah,
concept. So
but in one question itself, we are covering it's 3 to 4 minutes. It's like a real interview. I'm thinking like, okay, he's covering all like that.
yeah, this is how it
I
is
think
actually.
yes,
See, generally, and one more thing, you need to interact with clients. Okay, you need to slow down your speech because client
yeah,
should
okay,
the client should understand what
yeah. What
exactly
we
you're
are
saying.
saying.
Yeah, I know you're so enthusiasm, you know everything, but you want to,
Yes, sir.
yeah, but no problem. So just work on that, and yeah. So if you know concepts very well, I think you have done fantastic labs also, right? I saw it.
Yes, sir.
Yeah, so
Yes.
labs help you a lot now, right? Yeah, cool. And fine, there is a BGP path manipulation real-time projects also, right? Projects I
Yeah,
gave,
okay.
check that,
Mhm.
and I will cover that thing as well as network automation in part two. Okay, yeah.
Sure.
So this is
Yeah.
fantastic, and thank you so much, ma. And yeah, for me,
Thank you, Anna. Thank
I will give you a 9.5 out of 10 for your,
you.
okay.
Thank you. Thank you
Yeah,
so much for your
yeah. So
response.
yeah, everything is good. Just work on the speed. Okay.
Speed.
Yeah,
Okay.
yeah. Fantastic.
I will.
And yeah, thank you so much again. Yeah, bye, ma.
Yeah. Thank you.